I'm going to wait to save the streaming. Today I'm going to finish the articles about MEV and proposer builder separation. In proposer builder separation one, I'm gonna do just a simple article. I'm not gonna go into depth of each thing, I think. Just briefly explain what it is and the things that are involved, and then I'm gonna work on the other articles. And this one I'm also gonna just finish here based on the stuff that I wrote before and just add the whole thing about the MEV and the nodes and the transactions, the mempools, how it works. So I think I'm gonna start with the Italian stuff first, because I haven't done that in a long time.
Fa,
Fa,
does,
fisso,
fisso,
set, unchanging,
3,
tre,
3,
desiderare,
desiderare,
desire,
aria,
aria,
air,
bene,
bene,
well,
anche,
anche,
also,
giocare,
giocare,
play,
piccolo,
piccolo,
small,
fine,
fine,
end,
mettere,
mettere,
put,
casa,
casa,
home,
leggere,
leggere,
read,
mano,
mano,
hand,
portare,
portare,
carry,
grande,
grande,
large,
compitare,
compitare,
spell, words,
aggiungere,
aggiungere,
add,
anche,
anche,
even, also,
terra,
terra,
land,
qui,
qui,
here,
devo,
devo,
I must,
grande,
grande,
big,
alto,
alto,
high, tall,
tale,
tale,
such,
seguire,
seguire,
follow,
atto,
atto,
enact,
perché,
perché,
why,
chiedere,
chiedere,
ask,
maschi,
maschi,
men,
cambiamento,
cambiamento,
a change,
è andato,
è andato,
he, she went,
luce,
luce,
light,
tipo,
tipo,
kind, of thing,
spento,
spento,
turned off,
bisogno,
bisogno,
need,
casa,
casa,
house,
immagine,
immagine,
image,
provare,
provare,
try,
noi,
noi,
us,
di nuovo,
di nuovo,
again,
animale,
animale,
animal,
punto,
punto,
point,
madre,
madre,
mother,
mondo,
mondo,
world,
vicino,
vicino,
near,
costruire,
costruire,
build,
se stesso,
se stesso,
himself,
terra,
terra,
earth,
padre,
padre.
father,
Ethereum is one of the most popular blockchain protocols. Previously, it used to work with a proof of work model and now has moved to a proof of stake. The proof of work system, there is something called a miner, which is someone that offers computing power in order to solve a mathematical puzzle in exchange for tokens from the blockchain protocol. In Ethereum, these miners had the ability to build transaction blocks in a way that would maximize the amount of profit tokens they would make from each block. This article, I'm going to explain how this process of maximizing the amount of value a miner will get, more commonly called miner extractable value, has changed the Ethereum ecosystem and why it is one of the most important aspects of blockchain protocols. In order to have transactions processed, but people have to pay a fee. In Ethereum's case, it's called gas, so that the miner has an incentive to validate their transaction. The higher the fee gas, the higher the chance the miner will give that transaction a higher priority. Also, over time, people realize that there is a lot of value in knowing which transactions are going to happen first. I think this also is not required. Over time, people realize that there is a lot of value in knowing which transactions are going to happen first. So a lot of attacks started happening because of that. Some of the most popular were float running, sandwich attacks, bandit attacks, and DEX arbitrage. What is a mempool and how does it work? Before transactions become part of the official Ethereum blockchain history, they go through a network of nodes in order to validate them. This is called a mempool. An analogy would be an exchange where people place transactions, but they are not executed right away. They only happen after someone fulfills their order. The difference is that in Ethereum, the equivalent of someone fulfilling their order would be the miner validating the transaction and including it in a block. Because Ethereum works using a peer-to-peer network protocol, each node is only connected with a set of neighbors and not the entire network of nodes. Also, some of the nodes offload the work to mine for specialized GPUs and hardware that exists outside of the chain. I think here I should say explain, like make it clear that you can validate blocks outside of the blockchain. This means in Ethereum it was possible for a miner to fully validate transactions and build blocks completely outside of the chain and just sends the entire validated block, the entire block and just send the block entire nodes mempools only after we had already made it. This is one of the crucial points on why MEV considered to be a centralizing force. Because Ethereum works using a peer-to-peer network protocol, each node is only connected with a set of neighbors and not the entire network of nodes. Also, some of the nodes offload the work to mine for specialized GPUs and hardware that exists outside of the chain. This means that in Ethereum it was possible for a miner to fully validate transactions and build blocks completely outside of the chain and just send the entire blocks to other nodes mempool only after it had already made it. This is one of the crucial points on why MEV is considered to be a centralizing force. Because there is money to be made by observing the transactions that are happening and in what order they will be included in a block, a group of people start to specialize in creating bots that take advantage of these opportunities. These people are often called searchers. This becomes a problem for Ethereum, because it is a centralizing force, the miners that have the most computational power and the connection to the best searchers will gain more money and will reinvest it so they can even gain even more influence over the network. Because of this, what ends up happening is that these miners and wallet providers start to gain control. I think this part I'm gonna change because I want to explain. I want to make clear what it was difficult for me to understand in the beginning, and is the relationship between forks and the flow of transactions. Let me think. Maybe it would be good to create a different topic here. I think I'm gonna put just searchers here, and then I'm gonna put another topic here, and then write. Understanding transaction flow on nodes and poles. In proof of work, the official chain is the one that has the highest difficulty to solve, which is the one that is going to be the longer chain, because each block increases the difficulty for the next block. That has the highest difficulty to solve. So it's important to understand that at any given moment there can be different forks in the blockchain. There are multiple different histories can exist at the same time, and this will be let's say that node A receives 10 blocks per second, and node B receives 5 blocks per second. Because each node in the network is connected, eventually both of the nodes will receive all of the transactions. And the problem here is, since node A receives more transactions than node B, there is a delay for node B to update its history. Means it becomes more likely that nodes A will have control over the transaction flow of the blocks because it receives them transactions faster. This because as discussed earlier, the order of transactions really matter because and this is the part that is kind of hard to write. I think I need to explain RPCs before as well. So I'm gonna make one here. RPC or remote procedure. Oh, is the network. Let me read this stuff again. For transactions become part of the official blockchain, this common knowledge will be exchanged. Because Ethereum works using a peer-to-peer network, each node is only connected with a set of neighbors and not the entire network of nodes. Also, some of the nodes offload the work to mine for specialized GPUs and hardware that exists outside of the chain. This means in Ethereum it was possible for a miner to fully validate transactions and build blocks completely outside of the chain, just send the entire blocks to other nodes' mempools only after he had already made it. This is one of the crucial points why MEV is considered to be a centralizing force. Searchers. Because there is money to be made by observing the transactions that are happening and in what order they will be included in a block, a group of people starts to specialize in creating bots that will take advantage of these opportunities. These people are often called searchers. I think here I'm going to give an example because I realized now I was confusing both kinds of attacks. Front running is just when you get in front of someone for their order. So let's say you have a prize somewhere, like you have a smart contract that has a prize that if you guess the number, then you get the prize. Then you guess the number and you send a transaction, but you send the transaction in a public mempool. Then the person that is running the miner or that gets your transaction through the mempool, they see that you're gonna get the price and then they put their order before you with your stuff and then they get the price instead and your transaction reverts. And that's what front running is. And then sandwich attacks is when you buy something first, for example, like a token or something like that. It's kind of hard to think about examples because like I haven't seen it, but it has more to do with the like buying and selling things where you inflate the price first because you know that they're gonna buy or sell, then you do the opposite before them because then you know the price is gonna increase. So let's say someone is sending a huge order to buy a token because you know that they're gonna buy and that the value is gonna increase, then you buy before them and then you sell to them. Like, so that's the sandwich, and then you make the profit based off that. And then because of that, then people start competing for gas because then what happens is, like, obviously the more gas you put, the higher priority you have, then most of the money starts going to the miner. And because the miner builds the politics outside, because you can validate transactions outside, it becomes centralizing. Maybe this part is fine. Maybe I'll put the example here. Actually, whatever. If I do articles about these attacks, then I'll explain them more in depth. I think I'll leave it like this. Start specializing, blah blah blah. RPC providers. RPC or remote procedure call is a networking method used in programming to communicate between client and servers. This is what is used. This is what is used to connect the outside world to the Ethereum network. It is based on JSON commands that anyone can use in order to communicate with nodes in the network. So if you build your own node, you can configure it to determine who can have access to it in order to send transactions, allowing you to build an application that receives transactions and then relays them to your own node. Proof of work, the official chain, is the one that has the highest difficulty to solve, which is the one that is going to be the longer chain because each block increases the difficulty for the next block. So it's important to understand that at any given moment there can be different forks in the blockchain. So multiple different histories can exist at the same time. I said that node A receives 10 blocks per second and node B receives 5 blocks per second. Because each node think about whether I should change these numbers. Let's put minutes here. The second is not realistic, but just for the example, so obviously it doesn't matter. But Because each node in the network is connected, eventually both of the nodes will receive all of the transactions. But the problem here is, since node A receives more transactions than node B, there's a delay for node B to update its history, which means it becomes more likely that node A will have control over the transaction flow of the blocks, because it receives transactions faster. As discussed earlier, the order of transactions really matter, so node A will make the most money. Not only that, but if node A has connection to searchers, then what we can do is make an agreement with them to receive their transactions off-chain and build the blocks off-chain. And only then send those blocks through the mempool. This is what a company called Flashbots started doing. Connection to searchers, then what you can do is make an agreement with them to receive their transactions off-chain. Build the blocks off-chain, and only them send blocks through the mempool. Started doing. This gives them a massive advantage because they will anyone that sends transactions to them advantage because they won't be fronts. Be seen by other nodes once they are already included in a block. The flip side is they will have to trust should not censor transactions. Not only that, but if node A has connections to searchers, then what it can do is make an agreement with them to receive their transactions off-chain. Build the blocks off-chain, and only then send those blocks through the mempool. This is what a company called Flashbots started doing. This gives anyone that send transactions through them a massive advantage because their transactions will only be seen by other nodes once they are already included in a block. The flip side is they will have to trust the relayer. In this case, Flashbots. and the miners associated with them should not steal their MEV, prompt running them, stealing their DAX, arbitrage, etc., and should not censor their transactions. I think this part doesn't matter. Here, I think I'm gonna, yeah, I'm gonna delete this one. You might be asking yourself, why not just the reason why blocks exist is because of the fundamental data structures involved with the whole blockchain system. Like Marco, Patricia, Chris, and RP centralization. Because Ethereum is a Turing complete machine, but let me think about much read this. I think this part is kind of hard to. What I'm gonna say is that you have to charge gas to include transactions because otherwise you can have the halting problem. Besides, they will have to trust their video, blah blah blah. I think in this article about the MEV, I'm not gonna talk about the proof of stake. I think it's better to leave that to the proposer builder separation because then I have more stuff to talk about in the proposer builder separation. And then I can just link one article to the other. Because if I talk about here, it's gonna be too much. They're a lot way bigger than I thought it would be. Might be asking yourself, why not just make it so that nodes can only send transactions to each other and not full blocks? The reason why blocks exist is because of the fundamental data structure involved with the blockchains, the whole blockchain system. Ethereum uses something called EVM. Which is similar to rating systems. Right? It's not that similar. The thing is, I don't wanna, because then if I get into the specifics, I'm gonna have to search about the similarities and differences between the virtual machine and Windows and other systems like that, other operational systems. And I know that it's gonna get very complicated very fast. So, like, I wanna say that it's Turing complete, but then And I also like I understand these things on the concept level, but then to explain like the nuances and the details about what that means, it's kind of annoying. I don't want to do that. If I remember correctly, is any machine that can do if-else statements and loops, and that's Turing complete. And it's like you're imagining a tape, and then this tape has set of instructions, and then you can jump on the tape based on the instructions. So you can do pretty much all the computation that you need based on that. Because you can just put labels, and that's how the opcode system works. Like a function is just a label that allows the counter to go to the other parts of the tape. And then you have if-else statements, and based on that, like you can do everything because a loop is just a label as well. I could do but how can I say this? Simple nature by ensuring. Maybe I should be including pictures as well in these articles. Tape with infinite length. I don't want to do it. I don't want to select this. I just want to get the point across that you can't. You have to. What I want to say is that you need to use gas because otherwise someone can force. Maybe I should just say it like this. Because of the way is. Let me think. In order to perform computation, Ethereum uses something called a virtual machine. So I'm gonna do like this. Ethereum uses something called a virtual machine, EVM or Ethereum virtual machine. No, let me think how to say this. Because of the nature of this You might be asking yourself, why not just make it so that nodes can only send transactions to each other and not full blocks? The reason why blocks exist is because of the fundamental data structures involved with the whole blockchain system. In order to perform computation, Ethereum uses something called the virtual machine, EVM or Ethereum virtual machine. I'm not going to I'm not going to go, not going to go. Does that make sense? Maybe get is the correct way. I'm going to get into too many details here. Because of the nature of this virtual machine, it would be possible for anyone to make it execute a program forever. Because the EVM is single-threaded, meaning because the EVM is single-threaded, meaning you can only execute one instruction at a time. This would make the blockchain stop because it would be stuck executing that one program forever. In order to prevent this from happening, the idea of gas was introduced. This means that if you want a program to run, you have to pay a tip called gas to make it compute whatever you want. The gas you provided is not enough, the execution would stop and your transaction would be reverted. Make the computations efficient. It was decided that it would be better to batch them together into blocks using something called local tree. I'm not really sure if that's the best way to put it. Because there's so many different things here. Yeah, not because the way that I wrote this, it doesn't make any sense. Like because gas is connected to the size of the block, of each block, and not to like I think this is the it doesn't make sense. Because I want to say that like the decision to use blocks is because of the Merkle-Patricia tree, and the Merkle-Patricia tree connects everything into hashes and becomes more efficient. But it's also an arbitrary choice because there are other different ways to make the blockchain. Like it's not mandatory to have a Merkle-Patricia tree and to batch the transactions together, and that's also something that I'm thinking in my mind if it's a mistake or not in Ethereum, because I think that what matters is the whole thing that I was talking about, that is just it might be a fractal pattern, but that you have this gradient of distribution. So it's not clear like, what is the best data structure to make the whole network. Like in one side, you can make it so that each transaction is separate, and then each node has to validate the transaction. So instead of putting blocks together with hashes, you put each particular transaction together with hashes. But then you can think that, like intuitively, it would make sense that this is less efficient because every node would have to compute every transaction. So like it would have a lot of delay. And then on the other side of the distribution would have a situation where you have only one block ever, and that's also like the same thing. You go full circle because having one block and not having blocks is the same thing. Because then you would have to validate all the transactions anyway because you're just building a giant block, so it's the same thing. So across this distribution is where you have the complexity, and then you have these nuances of the decision of where to put the size of the block so that the network is efficient and is not centralized. But then you get into all this complexity of different nodes and the network latency and the power of the hardware of each node, and taking into account all the economics behind the infrastructure of the markets that are going to make the blockchain possible, and all these connections between relayers, miners, and all of the other people. So it gets into enormous amount of complexity if you're gonna talk about this. Like that's the issue that I'm having here thinking about. Because obviously in this article I don't want to talk about all of this stuff. It's too complex, and you like maybe I would make one article in the future just to talk about these things, but I want to cover all the other topics first, obviously. And there's also something that is really interesting to me that I'm thinking about as well, which is this whole thing about the size of the block and the structure of the nature of the data structure that is chosen to make the network. Another thing that I was thinking off stream yesterday is that it is very similar. A blockchain is very analogous to the way the body works, I think. Because if you think of a body, it works pretty much in the same way, where each cell is like a node of the network. And then the difference between the body and the blockchain of now is that in the body, different nodes have different purposes. And I think it depends on the DNA and the genetics. But each cell is going to follow probably a fractal pattern. Because I think that the reason why the things follow a fractal pattern is because of the principle of the least energy, let's say, where things tend to spend the least amount of energy possible, and that's why things become a fractal pattern. You can see this everywhere. So because of that, the cells are going to be very similar, and they're going to be different based on the specialization that is a consequence of the DNA and the way that it interacts with the whole body. And I think that the blockchain works in exactly the same way. So based on this intuitively, I think that there might be ways where you modify the structure of each node depending on the history, but then like what would be the DNA in this analogy? And that's where it gets complicated, because in order to understand the DNA, you have to encode the whole informational system across space-time of a species, which is the sum, like the not the sum, but the equilibrium of the differences in gradients between different tensors that make the network alive, let's say. Because the evolution is just going to be radiation, and the natural selection is going to be how the radiation evolves over time between the differences in the DNA of each agent of the network that is going to make up like the reproduction patterns and the hierarchies that form across the structure, and how that changes the environment and changes the impulse and closes the cycle. So the question is, how do you reduce everything into the DNA so you find the most optimal? It seems like an impossible problem, because then you get into the situation where it's not computationally reducible, because there's like you can't predict the innovation that is going to happen through the DNA that is going to modify the DNA at the end. So like you can't automate this process, I think. But it should be possible to create something analogous, because obviously it exists in nature, which is DNA. But I think that the whole evolution of blockchains is going to follow this path, where it's all about figuring out what data structure is the best in order to deal with these differences in flow of information that make up the blockchain. And I think that definitely proof of stake is probably not the answer, I think. Because it's just passing the problem, is like trying to solve the same problem in a different way using the same paradigm. It's not going to work, I think. But obviously I don't want to talk about all of this stuff here. Just want to keep simple as possible. It should just... So how can I say this? I think I'm gonna delete all of this stuff that I wrote here. This is a design choice based on from the people that's created your data structure that they decided to use was Merkle Patricia in order to keep different hashes of blocks and transactions in order to allow for consensus to work long term. Consensus should work. As in both work and proof of stake. Forgot the name. Byzantine census problem. Is general something Byzantine font? And it's very similar to poker as well, because of the whole game theory thing, imperfect information. It reminded me of that. I guess in the cells, like this is one of the reasons why I wanted to study cells as well, and the other thing, the other stuff. Because I assume that in the cells there's also imperfect information, and I remember studying that some time ago, where like obviously each cell is gonna have like a gate in order to decide if it's gonna allow something to enter the cell or not. So it works in a very similar way. So there's encryption in the cell to determine if the flow of information is gonna happen or not. So these are the pillars, like the consensus, the hash mechanisms, which is the encryption, and the flow of transactions or information in the network. How do you balance all this stuff out so that you have something that can regulate itself autonomously? And I know that Ethereum, I think Vitalik says that, or I read in some article that I don't remember, that they say that the purpose is not to be autonomous for Ethereum. But I think the overall goal for blockchains eventually it is to be autonomous. Because the way that I think about it, the blockchain is just the left side of the equation. Like AI is the right side and blockchains are the left side. And you need both sides to regulate. Because if you only have AI, then it's going to get out of balance because there's no mechanism to regulate the information. So it's either going to become too centralized and then becomes a vicious cycle and becomes destructive, or it becomes too decentralized where everyone has too much power and then also becomes destructive because everyone can build a virus that kills everyone else in their home. So there needs to be an encryption mechanism and like way to reach consensus over the encryption mechanism in order to coordinate the Internet of Things based on a set of hierarchy of values. And that set of hierarchy of values has to be, that's the hardest part because how we're going to reduce life into a set of values because it has to be anti-fragile. Because different parts of the network are going to evolve in different rates. That's what speciation is, I think. That's why different people speak different languages and then creates different races because there is fundamentally connected to the nature of space-time. So it's just the interaction of the electromagnetic field with space-time creates an informational system, and that is life. And that is an entropy reduction thing, where it's just a hologram. And because of that, then it needs to find the perfect balance between centralization and decentralization. And obviously, human beings are not good with that because we're not scalable, and that's why we're having all the problems we have because it's a natural polarization of our lack of ability to regulate ourselves in relationship to space-time. So everything becomes more polarized because technology increases and then there's no mechanism to coordinate and regulate. But the way that the Ethereum is done, I think like it doesn't make sense to just build on top of the same stuff. Like it's gonna break down eventually. I'll be right back. It looks okay, reconnected. So, maybe asking yourself, why not just make it so that nodes can only send transactions to each other and not full blocks? This is a design choice from the people that created Ethereum. The data structure that they decided to use was a Merkle-Patricia tree in order to keep track of different hashes of blocks and transactions in order to allow for the consensus to work. Because in both, proof of work and proof of stake consensus mechanisms, you need to find a way for multiple nodes to agree on the history. This is also commonly called the Byzantine. It's Byzantine general's problem. I should do an article about this, but I think I'm not gonna do it. I think conclusion now. Just spend too much time on this one. Transaction order. This one, not the most important things. Consider designing on blockchain. Because which is centralizing force. Creates MEV, which is centralizing force. As yes, in the I always forgot, I always confuse the symbol. The action order is one of the most important things to consider when designing a blockchain because it creates MEV, which is a centralizing force. In order to do with this, in the Ethereum network, it was decided to change the consensus, and the consensus was changed. I think that's it, probably. I think that's good enough. It's actually a lot more than I thought I would write, to be honest. Because in the beginning, just thinking about like on the concept level, and then like once you start writing about it, then you realize how much stuff there is to talk about for someone that doesn't know anything. It's really weird because you start taking it for granted, the stuff you know. Like it becomes self-evident after some point. And this happens with everything, I think. It's kind of like very similar to walking or doing things like that, I think. This mechanism where after you do something for a while, then it starts to become obvious to you, and then you forget how difficult it was to learn this stuff in the first place. Obviously, I'm not claiming that I know a bunch of this, but uh, you get the point. Like, I know a lot more now than I did when I started learning about this, all of this stuff. And I spent thousands of hours probably by now reading a bunch of stuff related to blockchains. Ethereum is one of the most popular blockchain protocols. Previously, we used to work with a proof of work model. And also, there's so much to learn still. It's kind of crazy. Like, I barely scratched the surface, I think, because there's so many different uh, consensus protocols and so many different functions and stuff that I don't know. It's really insane. Ethereum is one of the most popular blockchain protocols. Previously used to work with a proof of work model and now has moved to proof of stake. In proof of work system, there is something called a miner, which is someone that offers computing power in order to solve a mathematical puzzle in exchange for tokens from the blockchain protocol. In Ethereum, these miners have the ability to build transaction blocks in a way that would maximize the amount of profit tokens they would make from each block. In this article, I'm going to explain how this process of maximizing the amount of value a miner would get, more commonly called miner extractable value or maximum extractable value, has changed the Ethereum ecosystem and why it is one of the most important aspects of the blockchain protocols. Transaction order. In order to have transactions processed, people have to pay a fee. In Ethereum's case, it's called gas, so that the miner has an incentive to validate their transaction. The higher the fee, gas. I could put here the stuff about the halting thing, but I think I'm gonna leave it like this. Give the transaction a higher priority. Over time, people realized that there's a lot of value in knowing which transactions are going to happen first, so a lot of attacks started happening because of that. Some of the most popular were from 20, blah blah blah. What is the mempool and how does it work? Before transactions become part of the official Ethereum blockchain history, they go through a network of nodes in order to validate them. This is called a mempool. This is not uh, good because it's not exactly what's happening. Each one of these nodes has its own local history, which is called a mempool. You go through a network of nodes in order to validate them, which is called a mempool. Knowledge will be an exchange where people place transactions, but they are not executed right away. It only happen after someone fulfills their order. The difference is that in Ethereum, the equivalent of someone fulfilling their order will be the miner validating the transaction and including it in a block. It feels like I could come up with a better way to say that. This whole part of the mempool. Each one of these nodes has its own and a list of unconfirmed transactions or blocks. It's called mempool. Each one of these nodes has its own history and a list of unconfirmed transactions or blocks, which is called a mempool. I think that's good enough, probably. And I try to not be a perfectionist also, so I can write more articles and not worry about too much the nuances of writing. Because I think that it doesn't matter that much as long as people get the information that they are looking for. The difference is that in Ethereum, the equivalent of someone fulfilling their order would be the miner validating the transaction, including it in a block. This Ethereum works using a peer-to-peer network protocol. Each node is only connected with a set of neighbors and not the entire network of nodes. Also, some of the nodes offload the work to mine for specialized GPUs and hardware that exists outside of the chain. This means in Ethereum it was possible for a miner to fully validate. I'm not sure if it is or it was. I think it was. It was possible for a miner to fully validate transactions and build blocks completely outside of the chain and just send the entire blocks to other nodes. Mempools only after it had already made it. This is one of the crucial points on why MEV is considered to be a centralized form. Fully validate transactions and build blocks completely outside of the chain and just send the entire blocks to other nodes only after already. And this part is not good. I should fully validate transactions and build blocks. There are blocks to other nodes, mempool. To validate transactions and build. I think like I didn't want to write block because it's kind of repeating a lot, but I think it doesn't matter. Like this is more clear, I think. It's possible for a miner to validate transactions and build blocks completely outside of the chain and send the entire blocks to other nodes. Mempools only after the block was already built. I'm gonna leave it like this. This is one of the crucial points on why MEV is considered to be a centralizing force. And this is the other thing, because I didn't explicitly say, and maybe in the introduction here I said, I explained here. It's hard because I don't like. It's hard to put myself on the people's shoes that don't understand how it works. 'Cause I might be taking stuff for granted. I'm not really sure if it's a if it's clear or not based on this stuff that I wrote here. What is MEV? To say like this here. But I think I'm gonna leave it like this. Maybe I'll change it in the future. Another thing that I'm thinking about is whether or not to put the date to display the date. Oh, actually, I'm putting the date on each article, so I think I can change this later on the blog. Just create another div and then put the date there. I think I'm using a component, so I can put on inside of the component if I want. I think at some point I'm gonna do that because it's probably better to put the date, to display the date that the article is made. Especially when stuff like this that is gonna change all the time. Because there's money to be made by observing the transactions that are happening and in what order they will be included in a block. A group of people starts to specialize in creating bots that will take advantage of these opportunities. These people are often called searchers. RPC or remote procedure call is a networking method used in programming to communicate between clients and servers. Is what is used to connect the outside world to the Ethereum network. It is based on JSON commands that anyone can use in order to communicate with nodes in the network. So if you build your own node, you can configure it to determine who can have access to it in order to send transactions. Allow you to build an application that receives transactions and then relays them to your own node. Proof of work, the official chain, is the one that has the highest difficulty to solve. Which is the one that is going to be the longer chain because each block increases the difficulty for the next block. So it's important to understand that at any given moment there can be different forks in the blockchain. So multiple different histories can exist at the same time. Let's say that node A receives 10 blocks per minute and node B receives 5 blocks per minute. Because as each node in the network is connected, eventually both of the nodes will receive all of the transactions. But the problem here is since node A receives more transactions than node B, there's a delay for node B to update its history, which means it becomes more likely that node A will have control over the transaction flow of the blocks because it receives transactions faster. As discussed earlier, the order of transactions really matter, so node A will make most of the money. Not only that, but if node A has connections to searchers, then what it can do is make an agreement with them to receive their transactions off-chain. Build the blocks off-chain and only then send those blocks through the mempool. This is what a company called Flashbot started doing. This gives anyone that sends transactions through them a massive advantage because their transactions will only be seen by other nodes once they are already included in a block. The flip side is they will have to trust the relayer, in this case Flashbots, and the miners associated with them to not steal their MEV, front-running them, stealing their DAX arbitrage, etc., and to not censor their transactions. Why use blocks? You might be asking yourself, why not just make it so that nodes can only send transactions to each other and not full blocks? This is a design choice from the people that created Ethereum. The data structure that they decided to use was a Merkle-Patricia tree in order to keep track of different hashes of blocks and transactions in order to allow for the consensus to work. And this part's not good. Going into much detail. Such as without going into too much detail, this means that in order to make the consensus work, it is necessary to keep track of different hashes of blocks and transactions. Because of the nature of the data structure, it becomes more optimal to batch transactions into blocks instead of having to validate and send them to other nodes separately. Because both to validate and send them to other nodes separately. In proof of work and proof of stake, consensus mechanisms in which find a way for multiple nodes to agree on the history. It's also commonly called the Byzantine generals problem. This part, like I want to include it here because I want to talk about this, but it doesn't have, it doesn't go together with the rest of the thing. Maybe if I put it like this. Also debating whether or not to explain hashes, but I think probably not. Because then it gets into the whole another thing. Transaction order is one of the most important things to consider when designing a blockchain because it creates MEV, which is a centralizing force. In order to deal with this in the Ethereum network, the consensus algorithm was changed from proof of work to proof of stake, and something called proposer builder separation was created. More about it here. I think that's fine. So I'm gonna pass this one to the blog. I think after I will fix the interlinks after I have like a couple of articles from the algorithms as well. Because I wanna do all of these articles first. And there's a bunch like to make. The other ones I think I'm just gonna review them and I'm not gonna change much. The the articles about the programming algorithms that I made with ChatGPT. I'm just gonna review them and then because there's too many of them and I don't want to spend a lot of time focusing on that. I'm gonna focus more on blockchain. So let me think here. Also, I was debating the structure of this, like how to do it, because I'm gonna make the articles about the stuff more related to mathematics, Fermat's little theorem, and then I was also thinking about that there are several things that are connected, obviously, between blockchain and programming. Like, is the intersection between them, and a lot of these things are from mathematics. So I was thinking about in my mind how to structure this in the best way. Is that now I have a section for linear algebra in programming, but the blockchain stuff is very similar because it is. I'm not really sure if it's classified as linear algebra, but that's how I put it in my mind. This stuff about polynomials. But I think I'm gonna reserve the linear algebra on programming for things that are related to artificial intelligence. And then for things that are related for blockchain, I'm gonna put on the cryptography category, the mathematics of. But maybe I'll create. Yeah, I have to think more about this. Maybe I just put network, not network mechanisms. Yeah, I'm gonna delete this one as well. So now I'm gonna focus on proposer builder separation. So what can I say about this stuff? Oh, I forget. I have to do this. Design decision for the network consensus protocol on the Ethereum network. New design decision for. In this article, I'm going briefly explain And this is the part that I don't like about this. Is just thinking about a good way to write it. This to me it doesn't matter. I just wanna focus more on the information itself rather than like the structure of the sentence here and all this bullshit. And this probably not the best. And scalability. Change because of the centralizing force. I think this is good enough for introduction. Those are build separations and new design decision for the network and consensus protocols, the Ethereum network. The reason for this change is because of the centralizing force of MEV and scalability. This is this one I'm not really sure. Because there's probably a better way to say this. Centralizing force of MEV. This article I'm going to briefly explain what it is and how we changed the Ethereum protocol. So here I'm going to talk about sharding, which I'm going to have to study because I don't fully I understand that is a process of scaling a database. Like they got it from normal databases, the concept, where and I think this is the stuff that I'm not really sure about. I think, but I assume right now is for SQL databases, like it's more for, but maybe not. It's more for vertical integration rather than horizontal integration, I think. So let's say your database starts to get you start to get too much data, and then one computer can't handle the data anymore, and then you have to put on several different computers, and then you need to create schematics for the communication between all of these computers in order to synchronize the data. And so it's pretty much a mechanism to scale the database, and that's what's happening with Ethereum as well, and with the dank sharding thing, where it's it's stuff that it was put it that was I'm not sure if put is a word. stuff that they put on the network to make it so that there there can be more people validating and you can scale. So here, not sure if that's how you say it. Maybe before, not sure if that's how it says as well, clients, different types of Ethereum clients. Yeah, you should put consensus, execution, and validation. Maybe that's better. So this part I'm going to talk about the 3 different clients. I'm going to say that it was in proof of work, you only had one type of client, which was the execution and validation at the same time. Execution and consensus at the same time, because it was proof of work. And then when you moved to proof of stake, they decided to create 3 different clients because of the scaling issues. Because as the network grows, there's more data, and then because of MEV, it starts centralizing more, and then it becomes more. You need more and more powerful hardware to run the network. And this is obviously centralizing because then eventually only a few people can run the whole thing, and then it becomes they dictate what goes on the network. Then after this, I'm gonna have to do research, but I'm gonna explain what is link sharding or sharding, and then data availability sampling as well. But obviously, I'm not going to talk about the whole stuff related to this because it's gonna go into all of the other stuff about the Fermat's little theorem and then the polynomial stuff, all of those things. So maybe I think, yeah, it's probably better to do, like, because otherwise just gonna waste my time here, like building, it's better to build the articles that are gonna be part of this one first. So I should do an article about link sharding. One about link sharding and then one about Yeah, then I do a brief explanation here, and then I point to these ones. Like the thing that I'm struggling here with deciding is because I know I'm gonna have to do all of the algorithms articles, and there's a bunch of them. So I'm not really sure, like, because I want to have at least a couple of articles on blockchain before I go back to doing the algorithm ones. So this is the reason why I'm trying to decide my mind, because I want to finish these articles here. I think I'm gonna do. I need to do the smallest thing possible, so I'm probably gonna do the math ones first. I think I'm gonna do these ones first. But my concern is that they are really hard to do. 'Cause then it might take a lot of time. Yeah, but it's probably better. Do those ones first, and then after I finish those, then I talk about this other stuff. It and this one is gonna be here, data availability sampling. I think I'm gonna use ChatGPT to create the outline for this. Oh, I'm curious to see. The thing is that ChatGPT is older, so it's not gonna know all of this stuff, but I'm curious to see like what it's gonna come up with for the headlines. But I'm gonna do probably yeah, I'm gonna do these ones first, I think. These math ones, and then I'll go back. I need to structure in my mind as well what kind of things are necessary. I think for the thing is that I don't know too much about dank sharding, so but I think that it is gonna go hand in hand with data availability sampling because one is necessary for the other in Ethereum. But I don't know, I don't remember the math involved for each one. As I want to study these algorithms while keeping in mind the context in what thing they're used. That makes sense. So that later on when I write the articles I can know. Should probably do an article about the elliptic curve as well. The one used for the private keys and public keys. And should I put pictures as well? I think I'm gonna stop here. I might come back today later. I'm probably gonna do these ones next. I think I'm gonna follow this order here. Start with Fermat's little theorem, then go over these ones, and then only after I finish these ones, I create these. But I might also like I might go back to the algorithms once I finish these ones. I think that's what I'm gonna do. Like finish these ones first and then go back to the algorithm ones. Because the algorithms I'm probably gonna go faster because it's just reviewing, so it's easier. Like reviewing to see if it is correct, the information. And maybe rewriting a few things here and there, but it's definitely gonna be easier than this stuff here. So that's what I'm gonna do. But finish this one first and then go back. And then go back to the algorithms. And then After I do one of the categories of the algorithm ones, then I go back to this, come back to this one. And it's gonna be better this way because then I'm gonna force myself to remember after reading the articles. After making the articles about these ones, I'm gonna have to read a bunch of stuff probably about these other things here. And then I'm gonna remember, and it's gonna be better for spaced repetition. But I think I'm gonna go read something now. I might come back just tomorrow. Like it depends on how I feel and what I decide to do off stream. So yeah, if I don't come back today, probably I'll come back tomorrow.